In the last class, you wired up this circuit in order to measure the voltage transfer characteristics of a TTL NAND gate. Now we shall connect the power supply. The data sheet tells you that you have to use a power supply of 5 volts. So shown here is the power supply, and we pick the power output C, which is 5 volts 5 amperes. Avoid using A and B because you can technically overshoot the power rating. So you can connect the red wire, which is the VCC rail, to the positive terminal here, and the black wire to the negative terminal as shown here. So you take the wire and you bend it as shown here after stripping it, and you just circle the wire around that node and you tighten it. Repeat this exercise for the ground terminal as well. After you connect the ground, make sure that there is no metal protruding from the ground towards the VCC, because any short there can cause a very high current and a short circuit current between VCC and ground. So make sure that metal is completely isolated. The other end of the VCC and ground wires have to go to your VCC rail as shown here, and the ground rail which is on the other end of the breadboard. Now you're ready to turn on your power supply. So you go ahead and put it on. But before you go ahead and do any experiment, you have to measure it and make sure that it gives you the right output. So you create 2 probe wires and plug it into the power supply, and the other end of these probe wires go to a voltmeter which is reading a DC voltage, and that shows you about 5.08 volts. You can adjust that voltage using V set as shown here and obtain an exact 5 volts as shown here. The aim of this experiment is to vary the input voltage at pin 2 between 0 and 5 volts and see how the output voltage at pin 3 varies. So we need to connect 2 voltmeters, one between pin 2 and ground, another between pin 3 and ground. The input voltage is varied between 0 and 5 volts by tapping the output at the intermediate terminal of the trim pot and adjusting the resistance that goes to ground. And of course you have to use the voltmeter in order to measure the exact voltage that is being applied at pin 2. To ground any spikes from the power supply, you connect a capacitor between pin 2 and ground. Eventually your circuit should look like this. You should have added 4 probe wires on the breadboard, 2 for the input voltmeter and 2 for the output voltmeter. This probe goes to pin number 2 through the blue wire, and the other end is connected to the ground rail. Input voltage is measured using this voltmeter as shown here, which currently reads 0.944 volt. This probe is connected to pin 3, and the voltmeter shown here is used to read the output voltage of the NAND. Now your job is to vary the input voltage at pin 2 by tuning the trim pot. Turning the screw clockwise will cause the input voltage to decrease as shown here by the voltmeter, and turning it anti-clockwise will cause the voltage to go up. This is the expected plot that you should see. If you focus on the curve in between, temperature equal to 25 degrees, you will see that the output voltage starts falling rapidly the moment the input crosses 0.8 volt. This is VIL, the maximum input voltage that can be recognized as logic low. So when you tune your trim pot, please make sure that you change it in rather small steps the moment you cross 0.8 volt. So on the left, the black voltmeter is reading the input voltage, and the right is the output voltage. Until you reach 0.8 volt, the output is more or less the same. The moment you cross 0.8 volt, the output starts falling rapidly. So you have to capture enough number of points in this transition region to get your plot correctly. The next experiment is to measure the input current versus the input voltage. For this, we take the output voltmeter and connect it as an ammeter in series between the trim pot and pin number 2. To do this, you change the voltmeter mode from the volt to the ammeter side. You connect it to read a range of 20 milliamps. And since both volt and milliamp currents can be read from the same connection, you don't have to change the probe connections as shown here. Please ensure that the power supply has been turned off in the process of making this change. Now you have to ensure that this ammeter comes in series between the trim pot and pin number 2. For that, you have to break this yellow connection and connect the ammeter between these two ports, that is the trim pot and pin number 2. So you go ahead, use a screwdriver to remove this connection very carefully. And connect the red probe to the intermediate node of the trim pot and the black probe to pin number 2. Please connect it in exactly the same way, otherwise you will get a negative current reading. Like you did in the voltage transfer characteristics, you turn on the power supply and select the power supply C so that it gives you 5 volts 5 amperes, and then you can start tuning your trim pot in order to change the input voltage. You see that initially the current starts with a negative value of minus 0.1 milliamps, and as you start varying the trim pot, the input voltage starts increasing, and at some point the input current will approach a value of 0. Repeat this exercise for the output characteristics, where you connect the ammeter between the trim pot and pin 3 and a voltmeter between pin 3 and ground as shown in the circuit diagrams here. Do this for both states of the input, logic 0 and logic 1.